Hi, my name is Karen, and this is my study on the effects of ultraviolet radiation and temperature on biodegradation of polyethylene terephthalate using Bacillus subtilis. The objective of this study was to explore the effects of ultraviolet radiation and temperature on polyethylene terephthalate while maintaining the health of a pure strain of Bacillus subtilis. It was hypothesized that using UV radiation and Bacillus subtilis biodegradation at a temperature of 50 degrees Celsius, PET would exhibit significant loss of mass while the bacteria remains viable. 8 million tons of plastic are dumped into the ocean per year. Polyethylene terephthalate is the most widely used because it is durable and lightweight. Production has increased during the COVID-19 pandemic for personal protection equipment such as face masks. Unfortunately, PET can take up to 1,000 years to decompose and is accumulating in ecosystems, harming wildlife. Polyethylene terephthalate is a stiff molecule and lacks segmental mobility. It can withstand a wide range of temperatures, and shown here is the structure of its monomer, where N is the number of repetitions. The majority of plastics in the ocean are microplastics, which are easily digested by wildlife and difficult to extract. Microbial bioremediation is the use of microbes to decontaminate ecosystems by breaking down pollutants. This avoids the need for harsh chemicals and costly pollutant extractions, and can biodegrade plastic at a microscopic scale. Bacillus subtilis, also known as hay bacillus, is commonly found in soil, vegetation, and aquatic environments. It can naturally biodegrade PET, withstand UV radiation and high temperatures, and is easily accessible for researchers. In this study, the sample size was 60, which was split into 6 groups of 10. Group letters denote exposure to UV radiation and group numbers denote incubation temperature. First, I reactivated the bacterial cultures, plated them on agar, and took pictures of the plates. Next, I inoculated the samples in Luria broth and vials and recorded 3 turbidity measurements for each sample. Simultaneously to the bacterial preparation, I pre-treated the PET strips with UV exposure and recorded the mass before and after. After incubation, I extracted, sterilized, and masked the PET strips. Next, I measured the turbidity of each sample. Then, I plated 3 random samples from each group on agar and took pictures of the plates before and after UV exposure. Mass of PET strips was used to measure degradation. Although there was a slight % decrease, no significance was established between mean PET mass before and after incubation. A t-test was conducted comparing before and after measurements for each group. Group 1 exhibited no significance between mean PET mass before and after incubation, while groups 2 and 3 did. % change in PET mass was calculated for each sample. No significance was calculated between mean % change at each incubation temperature. Turbidity was used to measure bacterial viability in liquid suspension. Significance was established between mean turbidity before and after incubation. The difference in turbidity before and after incubation was calculated. Group 1 indicated a slightly larger difference than groups 2 and 3. Bacterial coverage was calculated using ImageJ software. No significance was established between mean % change for each group. Overall, UV radiation and temperature did not affect PET degradation during this experiment. The UV radiation did not cause a significant change in mean PET mass. Increase in mass after incubation was likely caused by the formation of a biofilm which was not removed during the sterilization process. Scanning electron microscopy could be used to analyze surface area changes such as biofilm formation and degradation. All incubation temperatures showed significant differences before and after incubation, indicating that the bacteria remained viable. No significance was established between % change bacterial coverage before and after UV exposure, indicating that the Bacillus subtilis remained viable. Shown here is sample 31 before and after exposure to UV radiation. UV radiation and temperature did not significantly affect the biodegradation of PET. Underlying factors that could have affected the results of this study include molecular changes of the PET monomer and formation of a biofilm. Bacillus subtilis remained viable after the biodegradation stage at all temperatures and exposure to UV radiation. The controlled environment does not reflect biodegradation conditions and could have been affected by other factors including moving salt water and broad-spectrum UV rays. Here are my selected references and image sources. Thank you for listening to this presentation. Have a great day.